So our software approach is to aim and set up, right? We want you to look at your products where they are as they come down your line, as they sit in their fixtures, and we want to look at them right there and tune the system to your product. So when we talk about autonomous, right, there's still a little bit of work on your end, right? If you're in an autonomous car, you have to tell the car, please take me to the office. Please take me home. Please take me to the coffee shop, whatever. Please take me to the bar. But once you've defined where you want to go, the car will get you there. In the same way, all you need to do is click on the product to say, this is my product. These are the areas I want to inspect. And these are things that I don't really care about, which you can see noted here in orange or yellow, which is the outline of the whole product we're looking for. Red is the inspection area. And blue are the areas we're wanting to skip over. Just clicking and making shapes, that's all you need to do. What does this look like in practice on an actual product? We're going to watch this video and find out. When you're making a new profile to inspect a given type of part, you give it a name, position the part under the camera. You can zoom in with our integrated optical zoom. Then you're marking the shape that you want to find. This is what the system is going to look for every product. Then you define the areas of interest. As you can see, there's tools for duplicating areas of interest, adjusting them, creating new ones using various shapes. It's a little hard to tell, but here we're looking actually at plastic pins on a connector. And from there, the system is going to figure out how to optimize the optical parameters to best see what you care about. So we don't have to adjust the lighting, don't have to adjust the camera exposure. It handles that for us. The second AI engine says, okay, great. Using this optimized exposure, I can now find these areas of interest, these regions of interest every time. From that point, you just have to give it good references. These are parts that you know they're good. You've inspected them by hand, and you put them through your assembly line. After that, the third engine can take over. Let's start inspecting. A part comes in. It is automatically recognized as the correct part with the correct shape. And if everything is in line with your references, meaning it matches the good parts you gave it, the part's accepted. So what we're looking for are outliers, things that look different from the good parts you've fed in. So here's some pins that have been bent or clipped or just cut. The part comes in, it's recognized as the part, but it is failed because the areas that we want to inspect are rejected. Let's see what another one looks like. Different pins bent or missing, or flattened in one case. And there you can see it. The red circles show us where the failures are, and the big red circle on the left shows us this whole part has been failed. So with one product, this allows us to tackle a range of applications: plastic and rubber injection molding, metal casting, PCBs, stamping, as well as a wide variety of applications. We can verify that your assemblies have been assembled correctly, that nothing is missing, or that there aren't any extra bits that are still there. We can look for debris that may have fallen on your part, oil, surface deformation. As well, we can also read any print on your part and verify that it's the correct part, and then feed that data to your PLC. This leads to a huge versatility of processes and applications. Metal, plastic, fiberglass, really doesn't matter. As long as we can see the part under the camera, we can probably inspect it and look for when something is out of bounds. This leads to a huge amount of variation. On the left, this is a part which is about 1.5 to 2 meters long. We're checking for the existence of certain components, but one camera is still able to check the existence. Now, on the other hand, if we look to find really small data, we can look at very small parts. It's all about how you set up the camera and the sort of defects that you're looking for. Whether you have complex parts with lots of detail, we can even detect when a bit of dross has fallen into the part. Damaged threads, not a problem. We can have the system set up to look for threads, and if it sees a variation in those threads, it will reject it. Metal forged parts, you can see these animated GIFs are sort of showing a good versus bad and how it's able to pick out the scars and defects in the forged parts. Injection molding. We saw a lot of people were asking about injection molding. Got any issues with short shots, burn marks, deviations in the shape of the plastic? We can detect that. And again, here we see this animated sort of good part, bad part, and compare that to the normal good part over on the right. Likewise, more missing material. This one's small, but there's a small defect down here towards the bottom. We can even look at multiple spots on a large part. So here we have a large part, about 2 feet by 2 feet, but by defining various regions of interest, we can inspect the entire part in one go. So if any of these holes are not present, or if something is bent where it shouldn't be, we can automatically get all that data back at once. Even small shifts that might be hard for an operator to notice, right? This is a small part of a larger assembly, but if this seal is not all the way in place, we can detect it, no problem. Metal and plastic, again, rejecting when something has been smashed out of place, right? When this was assembled, a bit of lubricant came out, able to be detected and rejected. Metal stamping, also not an issue. But even in complex parts where there's a lot going on, right? We can see that there's clearly other parts in the lineup around this part that we're actually inspecting, not an issue. It's a little dizzying to look at the animation, but the camera doesn't mind. As long as it sees and recognizes the part under it, it will accurately find the part, make sure all of the components you're told to inspect are there, and act accordingly. And for all of you who are asking about assembly, absolutely. We can make sure that parts are properly assembled, everything's fully clipped in place, and nothing is missing from your product. This even works on larger parts and arrays of parts. Say maybe you've got a pallet of parts. You can inspect the entire pallet to make sure that there's a part in every position and nothing has been knocked out of position. See, we see this one has been rejected because even though all these other ones are still in place, this one's missing. This even works on things like surface quality. So if you want to detect whether you've got a bit of debris or scraping, we can absolutely detect and reject it. And for those of you concerned about packaging, we can inspect packages, look for anything that is not supposed to be in the package view, make sure the package is properly sealed, read barcodes as needed, but the parts that are supposed to change, such as different labels, we can ignore those. So here we see an example of we're detecting whether these part number and serial number is printed correctly, but we are not failing based on whether this number here is changing. That number is supposed to change, so the system doesn't mind that it's changing. And we can even read this barcode to verify that the barcode or QR code matches the part number and serial number. That would actually be done on the PLC side, but we can still read this data and feed it out to the PLC so the PLC can do all of that validation and verification. All right, going to have another poll question. What is the most important factor for you in choosing a quality assurance solution? Poll should have just popped up on your phones and or computers. Got some votes coming in now. Great. A lot of people concerned about reliability, some ease of use. And how many different cases one system can handle. A lot of people out there are running high mix, low volume applications. So they may only run 100 or 1,000 parts. So of course, they're going to want to make sure that they get a system that can work on a wide variety of parts. You don't want to get a camera that only works on one product, but then the moment you switch products, it's no longer useful. Or a product that you've set it up and it took so much time, but now you've swapped products and now it's going to take what? Days to set up? No, you don't want to deal with that. You want something you can set up in minutes. So that's what we're trying to deliver on, and that's what we do deliver on. Thank you for that. Now I want to discuss types. People said they want to use lots of different product. We can allow multi-product inspection on the same unit. Really, no matter how many different parts you want to inspect on a camera, You can program unlimited different profiles, and you can swap between them manually, or you can have your PLC swap between them. So now, as long as the PLC knows what you're making that day, part of the changeover can be telling the camera, hey, this is what product we're running right now, either for the shift or maybe just for the next 3 parts. And the system can get the directive from the PLC to swap profiles and record accordingly. Now, having all of this data isn't super useful unless you can archive it. So we have the Tracks app to allow full archiving and traceability. You can search through all of your inspections. You can see the good parts, you can see the bad parts, you can see the parts that didn't quite fit in the window for whatever reason or were out of place. And this works even if you want to say, hey, show me everything from a given shift, regardless of what type it was, regardless of what profile ran. You can search for individual part numbers. For instance, we see this one here is labeled 1026, so I could search for that number, or I can search for a date range, whatever makes it easier for you. And as mentioned, our autonomous code detection and decoding. So while we're inspecting your product and passing and failing based on the presence or absence of components, we can also read all of the barcodes on the product, scan those barcodes, and feed that information out to the PLC. So you can validate that the thing that you are inspecting and processing is the correct product at the correct time. Everything that you need to have complete control over the product flow in your plant. This allows for a huge range of solutions. The most common is inline inspection, real-time integrated to the production line with PLC connectivity. Just mount the camera to your line and boom, you're off to the races. Or you could have an inspection station. This would allow you to load different kinds of parts. You could have different fixtures for each of the parts you wanted to run. And then if you wanted to sample some of the parts you're running at any given moment, you just load them into your inspection station and you're able to run. Or you could even try a mobile inspection solution. Mount the camera to a mobile station and just move it to wherever you need at the moment, clamp it in place, and then you can inspect that line for as long as you need. It's whatever makes things more convenient for you. You pick the solution that's easiest and going to pay off fastest. So perhaps you have a line that only runs for 4 hours, another line that runs for 8 hours. You could move the camera around from line to line and ensure maximum uptime. Let me check. I think we have one more poll. Now, this one's a more complicated one, but I do want everyone to sort of vote on it. Think right now, how many man-hours of labor, the labor you're paying for, goes into quality each day? Is everyone spending an hour pulling parts off the line, checking them out? Does someone have to come by and set aside parts and inspect them manually? Think about how much time that takes across all your shifts and all your employees. How many man hours do you think you're spending, even in one day, on quality? Please take a look at your phones and vote. The next question is the scary one. How much does it cost you if a single bad part makes it out of your plant? If you're a supplier for the automotive companies, we all live in dread of the great quarantine, where your plant could be shut down for hours or days while they validate what you've produced. But you may also be making electronic parts, so you're concerned about label losses, UL label losses. Or maybe it can factor in the time that it would take to audit your process. How many engineers would need to go into action to validate that the thing that happened will not happen again? I know this is a more complicated question, but hey, this is great feedback. We're going to give people a little more time. Because if you know how much you're putting into quality, you know how quickly an inspection station could pay for itself, right? An inspection station can work 24 hours a day, 365. And once you've installed it and paid for it, it's yours. A single inspection station working even 8 hours typically has an ROI of less than a year. In our case, for our product, oftentimes less than 6 months or even 3 months. And after that, it's all gravy. That's additional profit for your plant. All right, we had about half the people vote. And look at the cost, right? It can cost as much between $1,000 or $10,000 for a single bad part. So if you're able to inspect 100% of your parts and you catch one product that you would have otherwise missed, that's it. It's paid for itself. And everything beyond that is additional gravy, additional cost savings, additional money in your pocket. And because you can inspect every part, you can ensure that multiple parts in a batch don't escape your plant. Humans are great. The human eye, the Mark I eyeball is a pretty amazing tool, but humans are imperfect. We get tired, we get distracted, we make mistakes. With total quality assurance, you don't have to worry about that. And really, the future is now. You are the first people in the world outside of the company to learn about the advent of Inspekto 4.0, where we're going to be able to inspect parts not just that have been stopped on the line, but parts in motion as they pass by the camera. This really vastly increases the range of applications that Inspekto can work for. And we will eventually be moving into a cloud-based solution so that if you want to take all of the data from different cameras and have them in one repository, which you can then review, parse through, send to an ERP if you needed to, that'll also be coming out. So this is not just a current, oh, it works, but we're fine. No, we're always advancing, always changing the game, and we want to bring you along for the ride so you can continue to see benefits in your plant, in the awareness of your quality, so that you can continue to save money. Now, if you say, well, this is great, Daniel, but we still just don't have the manpower, no matter how simple it is, I just don't have enough time. I don't have employees. And for people that work in an area where it's hard to get good help, I understand that. So we also offer a whole suite of service options, subscription-based options, so that we can access your facility, access your plant remotely, and we can set up things. We can do use cases over the phone, all over the internet. We can validate what you're working on. We can even customize profiles to you. And if those 3 AI engines aren't enough, you need something really specific, or you got a part that just nothing else is working on, we can even do use case specific AI training. So if you've got something that's really just causing a headache for you, talk to us. We may be able to support you over the phone. We may be able to even do a use case over the phone. We've got systems we can send into the field, and we can help you set them up entirely remotely. But of course, if you've got a demo that's really burning a hole in your pocket, or you really need a proof of concept, we're going to be having an upcoming roadshow. Shimon and I have our shots. So in perhaps a month or two, we're going to be traveling the USA, visiting some of our existing clients, but we would also love to come visit you. So if this is something you're interested in, please get in touch with us, communicate us. We are happy to do a use case for your plant. And just as you've seen, we can spend a day and inspect every issue that's giving you a hassle, and we'll know for certain that it works before the day is out. And with that, I would like to thank all of you for participating. We have a little extra time, so I would like to see if there are any questions people have submitted. Shimon, have we had any questions submitted?
Yes, I have a list of questions over here. Just a second. I will try to fix them all one after one so we can praise them. So bear with me in a second, please.
Sure, sure.
One of the questions that I saw attending over here is if the Inspekto S70 is saving the data of the bad pictures.
Mm-hmm. Yeah, the Inspekto is saving all of the pictures it takes. So whether the product is good or bad, or whether it says, I think this is your product, but it's not in the right position. I think it got knocked out of position in your fixture. It's going to save that data. And if you've got a PLC connected, it will send that data to the PLC, and then the PLC can respond appropriately. So maybe you want to have an operator come in and put the part back in its fixture. Maybe you want to have the operator push the part off the line. Maybe you're going to have it automatically go into a reject chute. What you do with that data is up to you, but the data is always going to be saved. So if you come back and say, hey, why did this part fail? You're going to be able to look up that old data and look up that old image. No problem.
Another question that we have over here is, who coordinates between the different aspects, the mounting, the camera, the lighting, the sensor, and the software?
Okay, so everything that comes in that box is all one sort of unit. So it's one camera that mounts to one controller. So they're already set up to work with each other. They have standard optical zooms, they have standard cameras, they have standard light sources. So everything is the same from one box to the next. So it's all set up for you. You don't have to tune in anything. You don't have to specify which kind of camera you want because they're all the same. Here's a great question. What is the typical inspection time for the inspections you showed? Typical inspection time is about 1 second, although this may be dropping in the 4.0 that was just released. Shimon, can you speak to that?
Yes, we are about to release our latest version, where we will have the ability to inspect running objects on a conveyor, as an example. So those are one of the release that we are about to do so in relatively very short time. So we got in the past requests to have real-time inspection, which we couldn't support. But now, if you have this challenge, you're welcome to contact us. And during our roadshow or during a proof of concept process, where we'll be more than happy to show you how it's working.
Mm-hmm.
Few questions coming also about the technology or the subcontext of the technology. Do we need defected images?
Yeah, if that was not clear, we do not need defective images. So the way the references work is you're giving it good parts, known good parts. And we want to get sort of the normal range of what a good part looks like. So if there's like little scratches, but that's okay, great, those become references. That way the system will say, okay, there's a normal range. Some good parts look a little different than other good parts. But as long as they're basically good, that's fine. But anything outside of that range can be rejected. So the advantage here is that maybe you've got a particular defect that's driving you nuts, right? Not only will our system detect that defect as being different from a good part, it'll also detect any other defect that you haven't seen yet, right? Because if you tune in a system to the thing that's bothering you today, what if you miss the thing that is bothering you tomorrow? We wanted to get a system that would check everything and reject everything out of that normal good range, no matter what you've seen it or not.
And I will add on top of it that we wanted to took a different approach. We wanted to do such a thing on a single shot. So you can use the components, product that you have on your regular process without bringing a very defect components. So what you have on your line, you don't need to bring a golden parts, just the standard products that you have or the components, and you just inject it, quote unquote, to the Inspekto S70 to recognize this, and you're ready to go. And continuing this question, or another question in the similar arena, how can I be sure that the system solved my use case?
So basically, we do this by trying it on real parts, right? We want to be able to look at real parts and build the references using real parts. And then we can create, defected parts, not because the system needs them, but because we can verify that the system is working properly. So I could take a part and scribble on it. I could remove a component. I could induce a bunch of different errors, and then you'll see right then and there whether it can detect those errors or not. And if it can detect those sample errors, it'll probably detect any errors that you need to find. Now, there is a slight possibility that the system will be a little overzealous, right? You've built your references, then here comes a part that does look a little different from your references, but is still good. The product might get failed. Not a problem. You can add additional references to the system, and in this way, the system is continually learning, right? The system will say, oh, this is a good part. This wasn't one of my references, but okay, I'll add it to my reference pool, and now I know that this is also normal and acceptable. So maybe you've got different batches of feedstock. Maybe you got different batches of raw material. Maybe they have slightly different surface qualities. There's different colors. As you feed all of that into the camera, it will keep learning to say, aha, so if the color of the feedstock changes, that's not an issue. If the color of the component changes, that's not an issue. I'm only going to fail the parts that are actually bad. So it continually learns, just like a real employee would. Let's see, we have a couple other live questions. What is the largest part size we can inspect? So this is really about where you mount the camera. We showed a picture of a part that was about 1.5 meters, 2 meters long. But I will admit, we were mostly looking for part presence and part orientation. From that distance, I wouldn't want to make any guarantees about, like, say, surface defects, right? So the closer you are, the more information you're going to get out of the surface, the further away, the less information. So you're going to be mounted further away for looking at large parts, and you will get a little less information about the surface quality. If you need a ton of information over a very large part, you can mount multiple cameras. And I'll say, okay, this camera is monitoring quadrant 1, this has got quadrant 2, and they'll all work together to inspect the part for you.
There are two very good questions coming from Aaron. One of them is, how does the system deal with changing lighting condition? And the second one, did you have installation in which you are mounted on a cobot?
Okay. So because the system is automatically, right, we've got that first AI engine that helps us set up the exposure time of the camera. Maybe you're working and you set up the camera during the day, and then at night, well, the sun's not out, and so there's not sunlight coming through your windows. The system will automatically detect, hey, this part doesn't look as bright as it used to be, and it'll dynamically change the exposure time so that it compensates for changing lighting conditions in your plant. And as for mounting onto a cobot, yes, that would be another way to look at very large parts. So you could mount a camera onto a cobot, and the cobot could just move around and say, okay, profile 1, snap. Profile 2, snap. Profile 3, snap. This has been done already by one of our integration partners in Europe. Let's see, someone asked, do I have to stop the object during the inspection cycle? In the past, this would have been the case, but with the advent of Inspekto 4.0, no, we can now inspect product as they move by on a conveyor belt without the part actually stopping. This is a huge advancement for us, and it really expands what we can do with your system and with your assembly line. So now you no longer need to make sure the part is coming to a stop. The part can now move all the way through the camera without stopping, and we'll still be able to capture the image. Next question, is there a color camera now or in the future? There is not a color camera. We are focusing on grayscale. So we will not be able to detect changes in color unless there are drastic changes in the contrast, right? So dark green and bright pink may look very different to the camera, but dark green and dark red may look identical. Let's see. I have a very specific application for inspecting used parts for reuse. We built a prototype. When are you coming to Southern California? Please send us an email. You can see our emails are on the slide, which is still being shared. You can send it to me or to Shimon, or you can send it to info@inspecto.com, and we can see about arranging either an on-site video, or we can try to arrange a remote demo where you would send your product to me and I would just inspect it at my home lab, or we can work out something in between. All right.
Oh, thank you very much for your attendance.
Oh, we have one more question, then we will be bringing this to a close because I know people have to get on. What protocol does the unit use to communicate with a PLC? We have Ethernet IP, Profinet, or discrete I/O. So those are the 3 protocols that we are currently able to handle. All right.
Thank you very much, guys, for attending this first session, and we'll be more than happy to show you the Inspekto, to introduce you the Inspekto S70 and give you a first-hand experience. You're welcome to contact Daniel, me, or to info, and we'll be happy to visit you on our very short, our upcoming tour. It will take place during April or May.
All right. Thank you, everyone. And thank you for participating on our polls and for all of the great questions. We look forward to getting in touch with you in the near future. So have a great day.
Thank you.